So most recently we've been looking at expanding different algebraic expressions. So we've been multiplying binomials together, for instance. Today we're going to start taking a look at something called factoring. And factoring is the opposite of expanding. Today we're going to take a look at common factoring. And our goal is, I know what a common factor is and can use it to rewrite an expression as a product. So common factoring is related back to when we talked about lowest common multiples and greatest common factors. So today we're going to focus on greatest common factors to help do some common factoring. So a factor, some definitions here. A factor is a number that divides into a larger number evenly. And two-factor means to create a multiplication statement for something. And that's the same as just writing it as a product. So we know that product means multiplication. So we're going to start in example 1 here and talk about writing the factors of these two numbers. So if we're talking about the number 24, if we're going to list the factors of 24, the first number we want to start with is 1. 1 divides into every number, so we'll start with 1. And on the other end, I multiply 1 times 24 to get 24. And then I'll just keep working my way up here. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. And next we would hit 5, but 5 doesn't go into 24. So there are all the factors of 24. And if we do the same thing for 36, we start at 1, so we'll have 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. 5 doesn't go into 36, but 6 times 6 is 36. So we just have to list that 6 there once. So there's our list of factors of 36. Now, if we wanted to factor the number 24, if I was going to fully factor it, so some of the questions that we will do in this unit will ask you to fully factor something. And to fully factor 24, probably our best way to do that is, and you may remember doing this in elementary school, is doing a factor tree. So if I list a couple of numbers that multiply to give 24, and then I continue to break them down as far as I can, so 6 is 3 times 2, and 4 is 2 times 2. That's as far as I can go. They're all prime numbers. I can't go any further than that. And if I multiply those 4 numbers together, they're equal to 24. So that's what it looks like when we fully factor 24 using a factor tree. So now if we're talking about greatest common factor, if you look up above at the factors that we listed for 24 and 36, what's the greatest common factor? So if we work our way up here, so 36 isn't common, 24 is not common, 18 is not common, but the greatest common factor is equal to 12. So 12 is the biggest number that divides evenly into 24 and 36. Now, we're going to be working with numbers and letters, but we look at the numbers first so you get an idea of what it is we're talking about. So we've got a couple of monomials here. We've got this term and this term, and we want to find the greatest common factor for those terms. So there's some steps that we go through here. The first thing is we want to find the greatest common factor for just the coefficients. So the coefficients are 12 and 18. the biggest number that divides evenly into 12 and 18 is going to be 6. So that's the greatest common factor of 12 and 18. Now, which variables are common to both terms? So both terms have an x in them. Both terms have a y in them. Both terms don't have a z in them. Just the first term has a z. So those are all the common variables. Now we need to figure out the greatest factors of the common variables. So basically you're looking for the lowest exponent on that variable between all monomials. So if I look at x first, I've got x squared and I've got x cubed. So the lowest exponent there is 2. And if I look at the y's, I've got a y cubed, and I've got a y with no exponent on it, so there's actually a 1 there. So the lowest exponent is 1, so that's just going to be y. So x squared y is a common factor to both terms. So that means then, if I'm writing the greatest common factor for those two monomials at the top, it's going to be 6 together with x squared y. So we're going to try these two here, just find the greatest common factor. So remember, for greatest common factor, we want the largest number that divides into all three coefficients. So if I have 3, 6, and 9, 3 is the biggest number that divides evenly into all three of them. They all have an x in them, so x will be part of the common factor. And then I need the smallest exponent on x, and that's going to be 2. So the greatest common factor for those three terms is 3x squared. And if I look at the second list of terms, I got 3 terms here. So when I look at these numbers, 2 divides into all of them. But I also notice that 7 divides into all of them. So if 2 and 7 go into all of them, then actually 14 is going to be the greatest number that goes into all of them. And basically, if you were trying to find the greatest common factor, if we took the 14, the factors of 14 are 1, 2, 7, and 14. So when you're trying to find the greatest common factor of those three numbers, it has to be one of those 4 numbers. So start with the biggest number, 14, and 14 goes evenly into 28 and into 70 if you check on your calculator. So 14 is part of our greatest common factor. X is common to all three terms. The lowest exponent on x is a 1 on that second term. So that's just going to be x. You can put a 1 there, or you can just leave it as x. And y is common to all three terms. There's my y, and the lowest exponent on y is the 2. So that's our greatest common factor for those three terms. So let's take a look at how we use this information. So our goal is, when we get to this question where we're asked to find a common monomial factor, and then we'll actually do some factoring with it. So the first thing we do is we find the greatest common factor of the terms, just like we did on the previous page. So if I'm doing the greatest common factor here, 8 is the biggest number that divides evenly into all three coefficients. X is common to all three terms. The smallest exponent on x is 3. And there's no other variable that's common to all three. So 8x cubed is what I'm going to put there. So to go ahead and factor this now, I take that greatest common factor and I put it in front of a set of brackets. So I write 8x cubed and I open a bracket. And then I need to divide each of these terms by 8x cubed. And the answers I get, I'm going to write inside the bracket below here. So when I'm dividing 8x cubed divided by 8x cubed, that's just equal to 1. If I divide negative 16x to the 4, y squared divided by 8x cubed, if I divide negative 16 and 8, I get negative 2. And then remember, I subtract the exponents on the x's. So that's just going to be x1. And then y squared is part of the mix there as well. And on the end, if I divide 24x to 7y divided by 8x cubed, I divide 24 and 8 first, I get 3. I subtract the exponents on the x's, and then y is on the end. And remember that this expression in the bracket should have the same number of terms as the original question. Because if we were to expand this now, which is the opposite of factoring, our answer would be what we started with up there. So you can always double check to make sure that you've done that correctly. So let's try some questions here. So, first I have to find the greatest common factor. For 9, 6, and 3, 3 is a common factor. There is no variable that's common to all three, so 3 is my greatest common factor. I now need to divide each term by 3 to figure out what I get in the bracket. So if I divide 9x squared by 3, I'll get 3x squared. I divide negative 6x by 3, I get negative 2x. And I divide 3 by 3, and I get 1. So that's what my answer would look like there. And again, you don't have to do this. You can do this in your head if you wanted, but double check what you get. If I multiply 3 times 3x squared, I get 9x squared. If I multiply 3 times negative 2x, I get negative 6x. And if I multiply 3 times 1, I get 3. So I know that I factored that correctly, because if I work backwards, I would get back to the original question. All right, and the second one here, greatest common factor. 6 is going to be part of that. Every term has an x in it. And the smallest exponent on x is 1, so 6x will be our greatest common factor. Now I need to divide each term by 6x. So 12x cubed divided by 6x. 12 divided by 6 is going to be 2. And I subtract the exponents, so 3 minus the 1 on the bottom is going to be 2, so 2x squared. Now I've got a minus 6 divided by 6, so that's going to be a minus 1. And x squared divided by x is just going to be an x. And then 24 divided by 6 is a plus 4. And x divided by x is 1. So that's what the answer would be. So really what's happening here is these x's here just divide each other out. So that's why we're left with plus 4 on the end there. Okay, and this one we've only got 2 terms. Greatest common factor is going to be 7. Both terms don't have an a. Both terms have a b though. And the smallest exponent is squared. Both terms don't have a c. So that's going to be my greatest common factor. I'm going to have to divide both terms by 7b squared. So 14 divided by 7 is going to be 2. And then the a squared is just part of the mix there, so it stays. And then I subtract the exponents on the b's. So 4 minus 2 gives me an exponent of 2. And then I divide 21b squared c squared by 7b squared. So 21 divided by 7 is 3. So that's a negative 3 because the negative there. And b squared divided by b squared, that just cancels each other out. So we're left with c squared on the end for that. Last one here of these guys. Common factor is going to be 5. Every term has an m in it. m to the exponent 1 is our smallest exponent there, so it's just m. And then for the n's, every term has an n, and the smallest exponent on that is 1. So now I'm going to divide each term by 5mn. And when I do that, I'm going to get 5m squared minus 3mn plus, and you can see in the last one here, we've got 5 divided by 5, so they divide each other out. We've got m divided by m, so they divide each other out. And if I subtract the exponents on the ends, I get n squared. Okay, so that's how we do the common factoring. We've got one last question here. We're going to do this as a warm-up tomorrow in class, so I'm going to stop there and we'll tackle that one tomorrow. Thanks. See you tomorrow.